All right, question 5 from 6.3 by StatLab. The assessed in billions of dollars of four wealthiest people in a particular country are 31, 29, 25, 17. Assume that the sample size n equals 2 are randomly selected with replacement from the population of four values. After identifying the 16 different possible samples and finding the mean of each sample, construct a table representing the sample distribution of the sample mean. In the table, values of sample means that are the same have been combined. Okay, so first of all, we got to come up with the 16 possible samples. All right, so let's do, so we're going to have four possibilities for 31. We're going to have 31, 31, 31, 29, 31, 25, 31, 17. All right, you'll have, for 29, we'll have four possibilities. For 25, we'll have four possibilities. Okay, and 17, we'll have four. So it gives us 16. So we got to do for each of these. So let's do 29, 29, 31, 25, 17, 25, 25, 25, 31, 25, 29, 25, 17, 17, 17, 17, 31, 29, and 25. Okay, so we have all the sample size of all of these numbers when n is equal to 2. Now what you're going to do, you're going to go to summary stats, rows. We want var1 and var2 with the mean of all of these. Okay, so first of all, 31. How many 31s do I have here? 1. So the probability is 1 out of 16. How many 30s? 1, 2. 2 out of 16. 1 out of 8. 29. 1. 1 out of 16. 28. 2. 1 out of 8. Because it's 2 out of 16. 27. 27. 2 27s. So 1 out of 8. 25. Looks like 1 out of 16. 24. 2 out of 16, or 1 out of 8. 23. 2 out of 16, or 1 out of 8. 21. 1, 2. 1 out of 8. And 17. 1 out of 16. Check our answer. Well done. Next, compare the mean of the population. Compare the mean of the population to the mean of the sampling distribution of the sample mean. So first of all, the mean of the population, we would add these numbers up. So 31, 29, 25, and 17, and divide by 4. So 31 plus 29 plus 25 plus 17 divided by 4. So that's 25.5. That's the population mean. Okay, now we need the mean of the sampling distribution of the sample mean. So the sample mean, we got to add these up: 31, 30, 29, 28, 27, 25, 24, 23, 21, and 17. So if I add all those up, 31 plus 30 plus 29 plus 28 plus 27 plus 25 plus 24 plus 23 plus 21 plus 17. Divide that by how many do I have? 1, 2, 3, 4, 5. 5 on that side, so divide that by 10. So that is 25.5. So that they're the same. The sampling distribution of the sample mean and the population mean are both 25.5. The mean of the population is 25.5. Is equal to the mean of the sample means, which is 25.5. All right, so now check answer. That's right. Okay, part C. Do the sample means target the values of the population mean? In general, do sample means make a good estimate for the population means? Why or why not? The sample means target the population mean. In general, sample means do make good estimates of the population means because the mean is an unbiased estimator. That's it for that question.